Hello again, this is Mr. Hunter, and this is Kinematics Unit Notes 2. Before we continue on with speed, velocity, and acceleration and the difference between them, I would like to just review some of the stuff that I previously talked about. So kinematics is the study of how objects move, which is what we're studying this unit. And so then we have the difference between scalar and vector. And scalar, remember, is just size. It's how big it is. And vector is size and direction. We have various types of size and directions, various types like speed. Let's see, time is a scalar, distance is a scalar. But then we get into vector, so like velocity is a vector, acceleration is a vector, and different things like forces that have directions are vectors. So remember, is the distance is how far an object travels. It's a scalar since there's no direction, and the unit is meters. Remember, in physics, we now deal with meters, kilograms, and seconds. We no longer deal with feet, inches, and pounds. So displacement is the shortest distance between where you start and where you end. Most of the time, this involves drawing some type of triangle and using Pythagorean theorem to figure out the displacement that you went. So therefore, we did some examples with the previous notes. If you missed those, you can go back and check those out. But what I'd like to talk about now is continuing your notes. We're in the middle column. And so speed is simply how far an object travels in a certain amount of time, aka distance divided by time. And it's scalar because we don't give direction with speed. Now, a lot of you already know about speed. It's intrinsic. That's what I love about physics is you know a decent amount of the stuff that I'm teaching you intrinsically. So for example, when you get in your car and I'm driving next to you and I say, hey, how fast are you going? You say, oh, well, my speed is 30 miles per hour. But in this case, we now use meters per second. So you might say, hey, I'm moving at 15 meters per second or moving at 20 meters per second. So that's speed. Remember, it's a scalar, and it's simply how far you go in a certain amount of time. So then we have velocity, and velocity is speed simply with the direction. Same definition, but this time it has a direction. Technically, the formula for velocity is displacement divided by time. But as I stated here, in most examples, distance will equal displacement. And very few examples, they do actually ask you to find the velocity, and they'll give you a displacement vector, and you actually have to use that displacement vector to determine your velocity, which will actually be different from your speed. And like we said, it is a vector, so it's because it has a direction. And the unit is just like the unit for speed, which is meters per second. So the formula for speed, as we stated, is speed equals distance over time. And we know that the distance unit for distance is meters, and the unit for time is seconds. So it's really the unit of meters per second. In physics, it's really important that you memorize and know what the units mean. Because oftentimes as you will start reading in the problems, they'll say, hey, a car travels 20 meters. And you're like, okay, that's the distance. Or if it says, hey, the car was traveling at 20 meters per second, since it gave you meters per second, you know you have speed. Velocity is our displacement over time. And once again, displacement is still measured in meters. Time is still measured in seconds, so the unit is meters per second. Now, since we have speed and velocity, I also want you to know that there are different types of speed slash velocities. The one that we will use most often is usually this symbol. And when we put a bar over something, it means we're averaging it. So when we want to find, the average speed, we take the initial speed plus the final speed, and just like any number we average, we add up the numbers and divide by how many there are. And so since there are two numbers we are adding, then average speed or average velocity would be our initial velocity plus our final velocity divided by 2. And that's what these symbols mean. VI means my start velocity or my initial velocity. And VF is my final velocity. It's the velocity I finished at. So as I just stated, there are multiple examples of different types of speed, which we'll encounter here, but we won't deal with too much. The one that you will see the most is average velocity. So average velocity really is that distance over time. And then something we will also see is something called instantaneous velocity. Instantaneous, that is a huge word. Velocity. And that's the speed at any given point in time. So for example, I'm about to draw a horrible map of New York State. La, 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 and I'm drawing it backwards. Go me. Erase that because I drew it backwards. Okay, so here's New York City. Here's New York State. Looks like kind of a big triangle. Okay, here's my terrible drawing of New York State. It looks like the head of an animal. But anyways, here's Rochester, right? And I am originally from Schenectady, New York. And that distance is approximately, once I get on the thruway, it's about 212 miles. So between Schenectady and Rochester, it's about 212 miles once I get on the thruway. And so on average, it will take me about 3 hours to drive that distance. Now, in terms of finding my average speed, if I said, hey, in miles per hour, what is it? You would take 212 miles and divide it by 3 hours, and you would get my average speed for that distance. However, my instantaneous velocity, if I said, hey, once I got to Utica, at Utica, what speed was I going through when I went through it? That would be the instantaneous speed. It's looking at the entire journey and saying, hey, at this particular part, what was your speed? In Regents physics, we don't deal with instantaneous speed a lot. It's usually we deal with the initial and final, and we deal with the average. Okay, moving on. So I just wanted to show you that real quick. So the last thing and the last part of these notes is actually called acceleration. Acceleration, there we go. Acceleration is my change in speed over a change in time. Another way to put it, it's the speed of my speed, or how fast my speed is changing. So think about speed, right? Speed is how fast is my distance changing over time. Well, acceleration is how quickly my speed is changing. So this is also a vector because it includes direction, and the units are meters per second squared. So remember, acceleration is the speed of my speed. It's my change in velocity. So the acceleration is my change in velocity, and this triangle means delta. And you've seen it in math before, and it just means change, over my change in time. Now in physics, I will not, in the very beginning, I will not accept this equation. When I teach you LEPA, I don't accept that equation. The reason why is because students often forget what it means. What it really means is I take my final velocity and I subtract it by my initial velocity and I divide it by my change in time. Now the reason why I write T is because most cases, like 95% of the cases that you'll deal with, they'll tell you the change in time, or I'll tell you the change in time. Very rarely will you have to choose from a graph and choose the difference in time, but that's what you'll need to do. And so as I've already defined, Vs is final velocity and Vi is initial velocity. And so the unit is meters per second, right? Because that's velocity divided by second. So that really turns into meters per second squared. So the unit for acceleration is meters per second squared. So I definitely encourage you to, one, memorize the units, make sure you know what unit belongs to what variable. So if I say velocity, you can tell me meters per second. If I say acceleration, you know it's meters per second squared. And if I say distance, it's meters. So please make sure you have this in class first thing tomorrow. I will be checking it for a grade, and we'll do some practice with this. See you later.